What happens in a double displacement reaction? The cations and the anions, they do what? They switch. They swap partners, okay? So in a double displacement reaction, we've got some compound AB plus some compound CD. They will switch partners, okay? Cation, anion, cation, anion. The cation and the anion will come together to form some compound AD. And the cation and the anion will come together to form some compound CB. Is this ringing bells from when we learned types of reactions? Okay. Why is it that A and C cannot join together? Why is it that they cannot form a new compound? They're both cations. And same reason for B and D. They cannot bond together because they're both anions, right? We're going to have our cations and our anions switch partners so that we form a new set of products. Does it matter if I would have written it like this? CB plus AD. Does it make a difference the order in which I write my products? It does not, as long as they're paired with the correct thing. Okay? So today we're going to practice that. We're going to practice knowing our reactants, but not knowing our products, right? Predicting our products. So I need you to have a cation or an anion ready when I call on you. You're going to give me either a cation or an anion, and we're going to build a reaction here, okay? Lucy, give me a cation. Which one? Beryllium. So beryllium is Be plus 2. Luke, give me an anion. Give me an anion. Oxygen. What's the anion version of oxygen actually called? Oxide. So oxide is minus 2. How am I going to put those together into a compound? How are those going to fit together in a compound? Is it going to be Be2O2? It's just BeO. They're going to go together perfectly. So my first reactant is beryllium oxide, BeO. All right, Zeno, give me another cation for my next reactant.
Sodium.
Sodium is Na and it's plus 1. Jonah, give me an anion.
Argon.
Argon's a noble gas. Try again.
Ooh, chloride.
Chloride, okay? Cl minus 1. How are those going to go together? Just NaCl. So there are the reactants for our double displacement. We have to now predict the products. So if I'm going to predict the products, what is beryllium going to join with? Chloride. Okay, so I'm going to come over here and build it from scratch. I can't just do this, BeCl. I can't assume that since there's a 1 here and a 1 here on the reactant side, that will be true for the product side. I just can't. So I'm going to come over and build it from scratch. I'm going to start with Be, which I know is plus 2, and Cl, which is minus 1. So how do those actually have to go together? BeCl2, right? And I know they have to go together that way because of the charges, right? Remember, we ignore the plus and the minus, and we crisscross them down. So Be1Cl2. And when there's a 1 right there, what do? There's a 1 right here. What happens to it? Do we leave it as a 1 or can we just leave it off? We leave it off, right? We ignore that. Okay, what does my other product need to be? A combination of what? Na and O. So again, I'm going to build it from scratch. Na is plus 1. Oxide is minus 2. So those are going to go together. Lose the plus and the minus, crisscross them down, and it becomes Na2O. Okay, do you see how we took those reactants and we were able to predict the products by putting the outsides together and the insides together, right? That's what happens in a double displacement. The outsides come together and the insides come together. Now, is that reaction balanced? Is this reaction balanced? Can you see the fix without having to go through the list? I think so, right? I see 2 chlorines here, but only 1 over here. So that's going to be the adjustment I make, right? I'm going to put a 2 there And that gives me also 2 sodium. So I'm going to check over here. This has 2 sodium, so we're good to go. 1 beryllium, 1 oxygen, right? So once you get more comfortable with balancing reactions, you should be able to do it without the list, right? For simpler ones, we can do them without the list and just be able to see. How do we feel about that? Yeah, sorry, Bethany, go ahead.
So like whenever we're doing these reactions, are you going to want us to balance them?
Yeah, so our goal will always be build and balance. Okay. Build and balance, bless you. Okay, let's try another set here. Tell me, do we have any questions before we try another one? Okay. All right, Gwen, give me a cation. Magnesium. Joe, give me a polyatomic ion as my anion. Oxalate. Very nice. You're going to make me guess here. Oxalate is C2O4 minus 2. Is that right? It's like I've done this before. Okay, oxalate. How are those going to go together? +2 and a -2, they're just going to go together, right? We're getting so close to Valentine's Day. This is perfect, right? They just go together. Okay, fine. All right, MgC2O4. Remember this C2O4, that is oxalate. That's its identity. Do I need to include parentheses here? Like, give me a confident yes or no. No, because there's only one of them. I only need one of those oxalate. So no, I don't. All right? Ty, give me a cation for the next reactant. Scandium. Sc +2, I think. +3. Yes, you're right. Thank you. +3. Tim, give me an anion. Nitride. Did you pick one that went together on purpose? Oh, okay, good. All right, how are they? They're going to go together 1 to 1, right? So my other reactant would be SCN. Let me tell you why this is so important that they get reduced, right? If I was going to put SC3N3 and I were going to go balance my reaction, it wouldn't work, right? I have to make sure that these become reduced. Otherwise, it'll have trouble balancing, okay? So they fit together 1 to 1. That's really important. All right, let's look at our products. We're going to predict our products. So magnesium and nitride need to come together. Am I just going to write MgN? No, I'm going to tell you a lot of you will get into that bad habit of just bringing over whatever subscripts they had at the beginning to the end. And you can't do that. You have to start them over. So let's build magnesium nitride. Mg +2 and -3. Crisscross them down. Leaves me with Mg, what? Mg3 and 2, right? We're going to bring both of those down. My other product is going to be a combination between scandium and oxalate. Okay, scandium is Sc +3, oxalates C2O4 -2. So how will these fit together? Okay, we're going to ignore the plus and the minus. Crisscross. And so that leaves me with SC2, C2O4, 3, just like that, right? No, what do I need?
Parentheses.
I have to have parentheses, right? Because I have to tell I need 3 of these full molecules, right? That polyatomic ion, C2O4, is its identity, right? We can't split it up. We can't do anything else with it. That has to be our formula, right? So our final product is SC2, C2O4, 3. Okay, so let's try to balance now. Let's try to balance. I'm going to look right over here, and I see 3 magnesium. So the first thing I'm going to do is put a 3. That balanced my magnesiums, but what did it do to C2O4? It made it 3, which we already have 3 over here. So then I'm going to slide my eye to scandium. I have 2, but on the left-hand side, how many do I have? Only 1, so I need to put a 2 there. And that means 2 scandium and now 2 nitride. Over here, I see 2 nitride. Okay, do you see the bounce back and forth that happens? Do we feel pretty comfortable with balancing equations by now? Okay, very good. What I would like for you to do now, with the person sitting next to you, Bethany, you might need to go work with Paige, and Carl, you turn around and work with Ty. I want each of you on your own to come up with a single reactant. A single reactant. So you build a compound on your own, then you get together with your partner, use their compound, and you guys build and balance a reaction. Okay? So individually build your compound, and then bring them together as the two reactants and predict the products. Okay? So I'm going to give you about 3 to 4 minutes to try that with your partner.